Hello guys, welcome to my YouTube channel once again, and I want to talk about matrices. And under matrices, I want to talk about how to find the determinant and then find the inverse of that matrix and then solve given linear equations using the inverse method. Feel free to join, subscribe, like and share. I hope you will enjoy. So first of all, let us start with a given matrix. Remember, matrix that we're dealing here with is a 2 by 2 matrix, meaning it has 2 rows and 2 columns. Our first matrix is, let's say this one, 3, 6, and 2, 5. So this is an example of a 2 by 2 matrix. So for us to find its determinant, I'm going to take the product of leading array. So this one, I'm going to take this as my leading array and then subtract the product of the other diagonal array or diagonal. So my determinant, I'm going to denote it as det. So it's going to be 3 times 5, subtract the other diagonal, 2 times 6, and this gives me 15. This gives me 12. If you subtract, the determinant in this case is 3. Second scenario, you can have a given matrix as 4, 2, 1, 6. So this idea is very important because it's going to help us to solve the inverse of a matrix, and here the determinant will be 4 times 6, subtract 1 times 2. That means this is 24 minus 2. The determinant there is 22. So having known how to find the determinant, then the next step is to find the inverse of a matrix. The inverse of a matrix. For our case 1, our matrix was 3, 6, 2, 5. We got our determinant as 3. So for me to find the inverse of this, I'll first of all find the inverse of 3, which can be written as 1 over 3. And then pre-multiply my inverse by the matrix. Pre-multiply the inverse by the matrix as I change the columns. So that is 1 over 3. Multiply by this comes here and this comes here. They're going to interchange. 5, 3. And the other diagonal the sign is going to change. It was positive, so it has changed to negative. So when I open this matrix using a third, now my inverse is going to change to 5/3, and then a third times -6, that is -2. Third times -2, it is -2/3, while a third times 3 is 1. So I'm happy we have found the inverse of the matrix for case 1. So this will help us to solve a simultaneous linear equation using the matrix method. I hope you enjoy. Feel free to subscribe, like, share, and comment. Okay, so you have a given question here. Use the matrix method to solve the simultaneous equation. I have 2x plus 3y is equals to -2. 3x plus y is equals to 4. My first step, I'm going to rewrite this linear equation in form of a matrix, and then find the determinant, find the inverse, and then pre-multiply both sides by the inverse. So rearranging this in form of a matrix, I'm going to have, I'll separate the coefficients and the variables.
Maureen, what are you?
The variable here is x and y, so I'm going to write them there. On the other side, I also write this one in form of a column matrix. That is my step 1. Step 2, I'm going to find the inverse of my matrix here, 2, 3, 3, 1. Remember, start by finding the determinant, which is 2 times 1 minus 3 times 3. That is 2 minus 9. Answer is -6. Next step, find the inverse of that. Inverse of -6 is 1 over -1/6, and then multiply my inverse determinant by the matrix. So my inverse matrix is going to be -1/6 multiplied by the position changes, and this side the sign also changes. And now my inverse is opening the whole matrix using this color or the constant. So -1/6 times 1 is -1/6. -1/6 times -3, I'm going to have +1/2. -1/6 times -3, I'm going to have +1/2. -1/6 times 2, I'm going to have 1/3. Like that. So I have my matrix. The next step is now to pre-multiply my equation here by so that is my matrix. I want to pre-multiply both sides using my inverse. And remember my inverse was, so I'm going to multiply both sides. My inverse was negative 1 over 6, negative a half, and negative a third. Multiply also on the other side. Negative 1 over 6, a half, negative a third, well, I've pre-multiplied. Well, I have pre-multiplied by my inverse matrix. So this is the inverse, so this is the inverse on both sides. So the next step, I want to multiply a matrix. This is my inverse, and this is the matrix. If you try multiplying, if we multiply an inverse multiplied by the matrix, I'm going to have what we call an identity matrix. The inverse times the matrix itself, get an identity matrix 1 0 0 1. So we don't have to pre-multiply this side, because it goes without saying that a matrix times its inverse is 1 0 0 1, the identity. So I'm going to write it on this side as 1 0 0 1 as the results for this. But on my right hand side, I'm going to pre-multiply the inverse times this column matrix using row by column approach. So this is my row and this is my column. If I take negative 1 over 6 times negative 2, I'm going to have positive a third plus, if you take 1 over 2 times 4, you're going to get 2. Taken row times column, and then the down I have a half times negative 2, and I have negative 1 plus negative a third times 4, and I have negative 4 over 3. This side, if you take 1 times x, 0 times y, I have x. 0 times x, 1 times y, I have y, is equals to, adding this 2 plus a third, of course you're going to get 2 and a third, 2 and a third, and then if you take negative 1 plus negative 4 over 3, you're going to get negative 2 and a third, so it goes without saying that the final answer for the values of x is 2 and a third, and the value of y is negative 2 and a third. I hope you've enjoyed. Thank you.